Let's say we want to calculate the wavelength of a box. This box weighs 2 kg and this box is moving with a velocity of 5 meters per second. Now, we know that the momentum of this box, P, is equal to mass multiplied by velocity. And in this case, the momentum is going to be 2 multiplied by 5 to give us 10 kg meters per second. Now, to calculate the wavelength of this box, we use the equation that states that wavelength is equal to the Planck's constant divided by momentum, which can be translated as the Planck's constant divided by mv. So we know that the Planck's constant is 6,62 multiplied by 10 to the power of minus 34 joules second. Now divided by the momentum, which is 10 kg meters per second. Now this will give us 6,62 times 10 to the power of 6,62 times 10 to the power of minus 34 meters. So this will become the wavelength of this box. Now let us discuss on how did de Broglie come up with this equation. Now we have to understand that the formula lambda is equal to h over mc. What it tells us is that there is a relationship between mass and waves. So this relationship is given by the theory that is called the wave particle duality. So under this theory, we should understand that, for example, light can behave like a wave, and it can also act like a particle. The wave nature of light was demonstrated by the Young's double slit experiment, while the particle nature of light was demonstrated by the photoelectric effect. Okay, so we have to understand that the body mass that demonstrated this, Davison and Gamma, tossed electrons. We know that electrons are body masses, right? They have a specific mass. Then they tossed electrons on a double slit, the double slit that is identical to the Young's double slit experiment. When the electrons were tossed on a double slit, the electrons diffracted. Diffracted to show that really mass can behave like a wave under a certain conditions. So this is it about the de Broglie's equation and how to calculate the wavelength of a body mass. Now I hope you have learned something from this equation. Like the page, subscribe the page, share with your friends, and jot down some notes. Have a happy study hour.